In this last talk, we are going to go back to the principles, to the basics, and we started the unit talking about Maxwell's contribution to electromagnetics, to our knowledge of the world we live in. And if you remember, the great merit of Maxwell is just the synthesis of electricity, magnetism, and optics. And he's shown that light is just one kind of electromagnetic waves, of electromagnetic radiation, that we are quite fortunate because we can see it with our eyes without the need of any other device. While with the general radio waves we use, then we need antennas and devices that will be appropriate for this. This really immediately set up a search in all European universities and scientists to develop experiments that could show that radio waves could be behaving in exactly the same way as light does. And we have to merit this man, Hertz. He was a German professor, and he published his results on the research on electromagnetic and electrical experiments in a book that really gave the whole set of details of his experiments and asked the scientific community to try to duplicate them and convince everybody that those waves, they really existed and how they could be produced with the generators and the receivers they had at the time, which are quite different to what we know today. The experiments were carried out in around 1888, and I'm going to show you a couple of videos that really reproduce what Hertz did. And the reason I can show you this is because we have at the Polytechnic University of Catalonia in Barcelona a replica of the experiments. And during the centennial celebration, we really performed them, we repeated them, and I can show you some details of them. Now, the only transmitter he had is just this coil. And with a battery and some contacts, he could produce sparks. That's the only thing he could do at the time. This is a very well-known device because for many, many years, all the cars had something similar to this just to ignite the combustion in the chambers. And this was just the coil and the contacts that really were feeding the spark plugs in the car. And this is the only transmitter he could have. Then he had to build antennas, and he built two equal parabolic reflectors. They have a cylindrical shape. And here you see just the metallic part of the reflector and the wooden frame that really maintained it. This is the transmitter, and this is the receiver. If you look at the transmitter, in the focal axis of the reflector, there is once again good supporting there a dipole. And this is a very thick dipole, short is here, one of the sides of the dipole, the other, and here you have two balls. And from those two wires, we really connect the antenna to the transmitter I have shown you before. And this is just the transmitter. The idea is with the coil to produce sparks in this gap that will set in motion the electrons in the dipole. And the radiation from the dipole will be arriving to the reflector, and it will be focusing the radiation in exactly the same way as the light, a reflector in any light system we normally have at home. For the receiver, the same reflector, and this is just the receiving antenna. It's a longer one, it's in here, and it's a thinner one. That's the receiving antenna. And those two wires now carry the currents that are induced in the antenna by the incoming wave that was produced by the transmitter and goes to the back of the reflector to the receiver. And this is the receiver. The receiver, the two wires will come to it along those 2 points, and the receiver was just this ball and the tip of this cone with a spring that he could adjust the proximity, the gap between them. This is a very small gap because what the sparks he will be inducing here are really quite quick. And this is just the experiment. There was nothing more to this, but this has the basic parameters and the basic components we can find in any communication system. A transmitter, a transmitting antenna. We launch waves into space that will arrive to the receiver and will be collected and seen. And with this he could produce electromagnetic waves that could, in some way, he could prove that they behave like light. They have exactly the same properties as light does. Now I'm going to show you the two videos. This is just the transmitter. And here we have in the back of the reflector, we have the coil that will induce the sparks in this gap. You will see that from time to time it stops and then restarts again, because it's not simple to maintain continuously the flow of current in there. Let's see it. At the beginning, you will see that they are just adjusting the connection. That's why you see those wires moving from the back. This is just the receiver, the details of the receiver. Here, once again, you see the dipole and the wires going through insulators to the back. It's a replica of the original experiments he built. And now this is the transmitter. And certainly you have to see it at dark. And you can just be a small reflection of the balls, of the tips of the antenna of the dipole, of the transmitting dipole, and you see there the spark. It's quite a strong discharge in there, so there are plenty of electrons moving around from one side to the other of the dipole. As all, the spark is not that stable, it moves around from across the gap. Now it will restart again. And it has the typical glow, blue glow of the sparks in there. And this is just the transmitter. This is the only thing he could do at the time. Okay. Now, let's move to the receiver. In this case, you're going to see a short recording of a presentation by two professors, García Doncel and Adolfo Comerón, that have shown to the students just the experiments and explain the historical content of the experiments. This is going to be harder to see because we have to focus on the receiver, and the sparks in there are going to be weak. So let's start, and I will try to highlight the details. This is just the transmitter, coil, the capacitors and the batteries. And this is the receiver. And just to see the spark, we have to put there a camera and show the sparks on a TV screen. This is the transmitting, the spark that you saw before. It's exactly the same. With this setup, he could put reflectors in between, polarizers, and also here put a prisma that could refract the wave. this is the receiver, and this is just a reflector. This is a metallic reflector. This one. And it's blocking, so there is no spark to see in there. Now you will see that they are just receiving the reflector, so now the wave can reach the receiver. And soon we will start to see, I will try to stop for you, the sparks in the receiver. Let's see if I can do it for you. There you can see some of the sparks. I will try to go back a little bit in the video. It's a video recording and you always lose some. There they are. So this is the area you should be looking to see the very weak sparks that are present there. So I'll go back a little bit and I'll let you look to the sparks as the video progresses. Then what they did was just to put a set of vertical wires that are a polarizer. And depending on the orientation of the wires, you can completely block the radiation or just let it go through. And this is the same thing we can do with polarizers in optics. So this was just, once again, a replica of an optical experiment. Because, in fact, remember, the goal was to show that radio waves behave in exactly the same way as light does. So depending on the orientation of the wires, you could see sparks going through. And that's it for the experiment. This is just the basic fact that really shocked the scientific community in Europe and showed that waves could be produced. And it wasn't a long time after that Marconi set up his first telegraphic or radio telegraph systems to connect both sides of the Atlantic coast, the American and the European one, and big business started then. And with this, we conclude this unit. We have just tried to show you the basic aspects of the generation, transmission, and reception of electromagnetic waves. And in this case, the most basic aspect to remember is that to produce those waves, we need to have charges in motion somewhere in our circuits. And once this wave is launched into space, when the wave reaches the receiver, exactly the opposite things will happen. Those electromagnetic fields will just induce in the receivers the motion of electrons that we can extract information from them and just get the signals we want to afterwards process, and with this getting all the information we are really looking for. That's all for this unit.